Here's the equation for that. The future value for periodic payments. So A equals, it's the loan amount, the monthly, or the payment, each payment of R amount times 1 minus 1 plus I raised to the negative n, all divided by I. A couple wants to purchase a home for $20,000 has a $20,000 down payment and wants to make monthly payments of $2,100. If the interest rate on a 15-year mortgage is 6% per year on the unpaid balance, what is the price of the house they can buy? So we use this to calculate how much house essentially we can afford to buy. The amount of money they can pay for the house is the sum of the down payment and the present value of the payments that they can afford. Using this, A equals R to the 1 minus 1 plus I to the negative n divided by I. We're using that equation. Filling in the values. We have a down payment of $20,000. So filling this in, the monthly payments we can afford are $2,100. That's R. 1 minus 1 plus I, which is the interest rate. The annual interest rate is 6%, so that's 0.06. And they're going to make monthly payments, so that's 12 payments a year, raised to the negative n, which is 12 payments per year times 15 years. We have that all divided by the periodic interest, which is the 0.06 divided by 12. That's the formula we're using. I'm just going to right now tell you the answer, and the next thing I'll show you is how you actually get this all in the computer. But the answer to that, this equals $248,857 and officially 38 cents. Now that's how much you'll be making in payments, but we also have this $20,000 down payment. So adding that on, we'll find out that this couple can buy a house worth $268,000 and $857. $268,857. We're not going to worry about the 38 cents when we're talking about the price of a house. 2,100 times, starting a numerator parentheses, 1 minus parentheses 1 plus 0.06 divided by 12. Close that parentheses, raise the parentheses, and it's a problem, so negative 12 times 15, close the parentheses. Let's get out of the exponent, close the numerator parentheses, divided by, let's do denominator parentheses, of 0.06 divided by 12. Close the denominator parentheses, enter. $248,857.38. This equation, if you have a debt of $A with an interest rate of I per period, amortized by n equally monthly periodic payments, at the end of each period, the size of each payment is. So we can use this, if we know how much we're borrowing, we can use this to find out our equal monthly payments. That's what we're doing with this equation. So a couple wants to purchase a home with a price of $205,000 $100,000. They have $30,000 for down payment. If they can get a 30-year mortgage at 5% per year on the unpaid balance, what are their equally monthly payments? Well, the first thing we're going to have to do is how much are they borrowing? They're taking the $2,500 and they're subtracting the $30,000 down payment, so they're borrowing $175,000. That's how much they're borrowing. That equals my A. So R equals the A, $175,000 times the equation 1 minus parentheses 1 plus I, which is R, the annual interest rate, 0.05, divided by the number of monthly payments, which will be 12, raised to so first we'll find out that we have $2,500. We subtract the $30,000. Well, they'll be borrowing $175,000. That's my A. So my R equals the A, $175,000 times, now I on top, which is the 0.05 divided by 12, that's the numerator. The denominator is 1 minus parentheses 1 plus I, which is R over K raised to the negative N, which is K times the number of years. If we do this calculation, we find out that the equal monthly payments are $939.44. Now that's the amount of payment on the loan. $939.44. How to calculate this figure in the calculator. First, we have 175,000 times the numerator parentheses 0.05 divided by 12, close the numerator parentheses, divided by denominator parentheses 1 minus parentheses 1 plus 0.05 divided by 12, close the parentheses, raise that parentheses to negative 12 times 30. It's my exponent. Get out of the exponent, close the denominator parentheses, enter. $939.44. That